Okay, this is the review for the chapter 4, 6 through 8 test. The very first type of problems that you're going to have on the test, or one of the very first problems you're going to have on the test, is a problem that looks like this. 42, the cosecant of the arctan of negative 12 over 5. And these problems are the problems that we had done earlier this week. And I didn't get through all of them. And then Haley had actually asked for me to do some of them in class, remember? And I did them on the board. So what you need to notice about these problems is that I have two different functions. One is cosecant and one is arctan. Since they are not the same type of trig function, I have to do the let u substitution concept. You with me? So you're going to have let u equal the arctan of negative 12 over 5. That negative is in the middle of that fraction. The negative is in the middle of the fraction. It is your responsibility to determine if the negative goes to the top or if the negative goes to the bottom. What does that mean, Mrs. Yoder? You have to determine the quadrant that you are in. You with me? What do I mean by that? Is when you're dealing with arctangent, you are between negative pi over 2 to pi over 2, correct? All of your answers, your range values, must be in between negative pi over 2 to pi over 2. So this means I am going to be between quadrants 1 and quadrant 4. Plus, 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 and plus, minus, minus. So what quadrant are you in if your tangent is negative? You have to be in quadrant 4. That is super duper important. So how do I get rid of arctan? Take the tangent of both sides. So I have the tangent of u is equal to negative 12 over 5. Where does that negative go? It has to go to the top because tangent is understood to be y over x. So since tangent is understood to be y over x, I need to find x, y, and r. Do we all understand that? My y in quadrant 4 is what is negative, so negative 12 goes to y and 5 goes to x. Do we all understand that? Yes? Okay, now what do I need to find? I need to find r, and what do we know r to always be? Positive because it is a distance. So I need to find r by taking x squared plus y squared is equal to r squared. So this is going to be the square root of 25 plus 144, which equals r. So this is square root of 169 is equal to r, so 13 is equal to r. Do we all understand that, yes or no? Now, if you recall, I said that u is the arctan. So you know what I can do? I can make a simple substitution there. And I can say, oh, well, what I'm actually calculating is the cosecant of u. What is the cosecant understood to be in terms of x, y, and r? Cosecant is the reciprocal of what trig function? Sine. So what's the reciprocal of sine then? R over y. So my r value is 13, and my y value is negative 12. So there is your cosecant of the arctan of negative 12 over 5. Do we understand that? Another one. Go ahead and start it, please. Why do I know I have to do the let u equal part here? Because my trig functions that I'm given in the problem are not inverses of one another. So I have got to do the let u. So this is going to be let u equal the arc sine of 3 over 5. When you are talking arc sine, what quadrants do my angles have to lie in? Arc sine is the same as tangent, arctan. So that's what quadrants? So that's negative pi over 2 to pi over 2. So it has to be in quadrant 1 or in quadrant 4. What quadrant am I in if my arc sign is positive? I have to be in quadrant 1, which means my x value must also be what? Positive. Do we understand that? Okay, so we're going to go ahead and take the sine of both sides. So I have the sine of u is equal to 3 over 5. What is sine described to be in terms of x, y, and r? This is going to be y over r, which tells you that I need x, y, and r. Y is 3, r is 5. I need to find x. How do I go about finding x? X squared plus y squared is equal to r squared. So x is going to be equal to 25 minus 9. Take the square root of that. So x is equal to the square root of 16. So x is equal to plus or minus 4. And what did we say we were going to utilize at the plus or minus? Only the positive, because we are in quadrant 1. Do we understand that? And in quadrant 1, x is positive, and so is y. So therefore, x is 4. And the problem that I am now talking about is going to be what? The secant of u. The secant of u is the opposite of what trig function? The cosine, and cosine is determined to be x over r, so the secant is going to be r over x. So r is going to be 5 and x is going to be 4, so there is going to be your answer. We'll have 2 of those problems on the test. Do we understand that? Any questions over what I just talked about? Excellent. Moving right along. The directions are going to be express theta using an inverse trig function. Express theta using an inverse trig function. So I want a theta equals, but in order for me to get a theta equals, I should probably get a trig function first. So if I have theta in there, can you tell me what is the relationship between theta and 4? It is adjacent. What is the relationship between theta and x? Hypotenuse. What trig function deals with adjacent and hypotenuse? So the cosine of x, or theta I should say, is equal to adjacent 4 over hypotenuse x. Now, what did I say the directions were? To make this theta equals using an inverse trig function. Yes? So how do I get rid of the cosine if I'm solving for theta? Arc cosine of both sides. So I'm going to have the cosine inverse of the cosine of theta is equal to the cosine inverse of 4 over x. Cosine and cosine inverse cancel out, so theta is equal to the cosine inverse of 4 over x. Cosine inverse and arc cosine are essentially the same things. Yes? Do we all understand that? You will have 2 problems like this on the test. Any questions? Can you do it? Next. How do I do this? The arc cosine of 1/2. When you're doing the arc cosine of 1/2, what does that actually mean in your head? Okay, first of all, when utilizing the arc cosine, what quadrants am I allowed to be in? 1 and 2, because this actually goes from 0 to pi, which means I am going to be from quad 1 to quad 2. Correct? This is the plus plus, this is the minus plus. What quadrant has a cosine of positive? It has to be in quadrant 1 that we are in. Do we all understand that? So the question you ask yourself is, what angle between 0 and pi, particular 0 and pi over 2, has a cosine of 1/2? What angle has a cosine of 1/2? Hands of the clock. 0, 1, 2, 3 is cosine. 0, 1, 2, 3. So it has to be 60 degrees, which is the same thing as pi over 3. Do we understand that? Same exact philosophy here, except for now I want the cosine of 0. As soon as you see a 0, you need to think quadrant angles. So you are going to draw your quadrant angles, and you're going to put on the ordered pairs associated with those quadrant angles. Do we understand that? Yes? So what angle has a cosine of 0? 90, which is the same thing as pi over 2. Do we understand that, yes or no? Okay, let's keep on going with that concept in your brain. How do I do this problem right here? The arc cosine of the cosine of 7 pi over 2. Is this a let u problem? Is this a let u equal problem? Why is it not a let u equal problem? You're correct, but why? Because we're talking about the same type of trig functions. I have cosine and arc cosine. They're inverses of one another, so I don't have to let u equal anything. What I need to determine is I need to work from the inside out. So if I'm working from the inside out, that means that I need to calculate the cosine of 7 pi over 2. Well, where is the cosine of 7 pi over 2? Where's 7 pi over 2 located at? Well, that's a really easy concept. Here's 0. Here's going to be 2 pi over 2. Here's going to be 2 pi, which is the same thing as 4 pi over 2. That's going to make this 6 pi over 2. So where's 7 pi over 2? 7 pi over 2 is right here. 7 pi over 2 is the same thing as 3 pi over 2. And the ordered pair that corresponds to that is 0, -1. Correct? What we just did is we located the coterminal angle to 7 pi over 2. Coterminal angle of 7 pi over 2 is the same thing as the cosine of 3 pi over 2. And what is the cosine of 3 pi over 2? It is 0. So what we're essentially doing is if I make a substitution here, I'm going to be doing the arc cosine at 0. Okay, so that brings me right back to the concept of where am I allowed to fall if I'm utilizing arc cosine? I'm allowed to fall between 0 and pi, which puts me in quad 1, which is plus plus, or quad 2, which puts me in minus plus. However, I'm 0. And what did I say whenever we see the number 0 or 1? What are we usually landing on? Our quadrant angles. So immediately you want to put on your quadrant angles. 1, 0, 0, positive 1, and -1, 0. So which angle has a cosine of 0? 90, which is pi over 2 radians. Do we understand that problem, yes or no? Same exact process here. The sine of the arc sine of 0.7. The sine of the arc sine of 0.7. Is this a let u equal? It is not, because those are inverses of each other. So immediately what my brain needs to think about is where do my angles have to fall when utilizing arc sine? Between -pi over 2 to positive pi over 2 is where my angles have to fall. So with that being said, oh, thank you. Thank you, though. With that being said, -pi over 2 to positive pi over 2, that's going to put me in quadrants 1, plus plus, and 4, plus minus plus, or plus minus, sorry. Correct? Now, here's the problem. My angle that I'm looking, my number that I'm looking at is a decimal. Are these decimals? -pi over 2 to pi over 2 is not a decimal. So what is the equivalent of -pi over 2? What decimal is that? -1.57 to positive 1.57. Is that within that region? Absolutely. So since it's within that region, what can I do with the sine and the arc sine? I can cancel them out to give me 0.7 as my answer. Do we understand that? Same exact problem, but except for this time, I'm going to be doing 2.18. 2.18. Is 2.18 in that region? No. So can I do the problem? No, this does not exist. This is not possible. It's undefined within that region. Do we understand that? So I can't do that problem. Make sure that you can do that on the test, that you understand the differences between them. Okay, that brings us to the next concept. I'm going to skip these ones for a moment. Okay, I give you this triangle, and this is the information I give you. I give you angle A is 20. I give you side B is 10, and that angle C is 90. Find the rest of the triangle. Find the rest of the triangle. Well, how do I go about that? I'm going to immediately draw my triangle. There's my triangle. I'm going to put C here, that's 90. I'm going to go ahead and put angle A here. Angle A here is going to be 20. Opposite A is going to be little a, I don't know it. Here's angle B, I don't know angle B, but I do know opposite it is going to be 10. And little c, I don't know either. Correct? Okay. So what can I find immediately? How do I find angle B? Angle B is going to be 90 degrees minus 20 degrees, which appears to be 70 degrees. Correct. Now, when you are doing these triangle problems, what did I tell you to do always if at all possible? Use the given information, because the given information is where less calculational errors are going to take place, yes? Using your information is where rounding errors and just keystroke mistakes happen, yes? So by going ahead and using the given information, life becomes a little bit easier. So if I want to find angle, let's say side A. What is side A according to angle A? It is opposite. What is the given value B directly related to angle A? What is that going to be? Adjacent. And can anybody tell me what trig function that deals with? So the tangent of 20 degrees is equal to my opposite, which is A, over my adjacent, which is 10. Would you all agree? So I have 10 times the tangent of 20 degrees is equal to A. When you are doing these problems, it is 100% essential that you watch the mode that you are in your calculator. If you are not in the correct mode, guess what's going to happen? You are really going to mess that up. So you are going to have 3.64 is equal to little a. So side A is 3.64. Correct? Now, there's multiple ways you can find side C. How do I find side C? Give me one method. She says cosine. Cosine would absolutely work. The cosine of 20 degrees is equal to the adjacent leg, which is 10, over the hypotenuse, which is going to be C. What's another way you could have used? Pythagorean theorem, it's a right triangle. So you say potato, I say potato, it really doesn't matter. So I'm going to have C is equal to 10 divided by the cosine of 20. So if I take 10 and divide it by the cosine of 20 degrees, it's going to give you, my thumbs are not hitting the right keys. C is going to give you 10.64. Do we understand that, yes or no? Okay, now, yes, ma'am. Yes. Okay, do we understand this? The only other thing that you are going to have to do is going to be, if I give you this triangle right here, and I tell you this is 3 and this is 5, This is 90. And this is C, this is A, and this is B. And I need you to find the rest of the triangle. How would you go about that? What's the very first thing that you would do? Pythagorean theorem, right? So A squared plus B squared is equal to C squared. So you're going to have a 3 squared plus B squared is equal to 5 squared. So B is going to be equal to 25, take away 9, the square root of that. So B is equal to 4, correct? So angle A, angle B, angle C, side A, side B, side C. So B is equal to 4, A is equal to 3, and this is 5, and this is 90. So how do I find the rest? How do I find angle A? I'm always going to use the given information, which was 3 and 5. So how do I find angle A? How do I find it? What is 3 according to angle A? Opposite, and this is what? Hypotenuse. So the sine of angle A is equal to opposite 3 over hypotenuse 5. I need to solve for A. So how do I get rid of the sine? Can't divide by sine. Arc sine is what cancels it out. So A is equal to the sine inverse of 3 over 5. So that means angle A is going to equal 36.87 degrees. So if that's angle A, how the heck do I find angle B? How's angle B found? You could. What's the more obvious thing? Nope. Great. 90 minus 36.87 is going to give you the 53.13 degrees. That's so much easier, wouldn't you agree? Why do trig if you can do subtraction? Do we understand you'll have 2 problems like that on the test? In addition to that, you are going to have 4 application story problems. Those 4 application story problems, it's really important that you get this. There's a lot of bearings. There's a lot of bearing problems, okay? Distance and bearing, so make sure that you're looking at that. And remember, whatever letter they give you first, if they give you east 32 degrees north, you're touching the east axis and then going toward the north axis. Do we understand that? If I say south 52 degrees west, you're touching the south axis and going toward the west axis, and it's going to give you that 52 degrees, okay? Okay, the last thing I want to talk about is part A test. And part A test is graphing secant, cosecant, tangent, and cotangent. And we haven't done this for a while, so let's make sure we have a little bit of a refresher course here real fast. We don't have much time remaining. We're out of here in 6 minutes, so I'm probably going to give the Cliff Note version of this. When we graph the secant, what am I thinking of graphing first? I have to physically graph the cosine of 5x plus pi minus 3. Yes? You still need to find your amplitude. You still need to find your max, your level, and your min. Yes? You still need to find your period. How do you find your period? Still going to be 2 pi with the absolute value of b. How do you find your interval? Your period divided by 4 is correct. How do you check that your period, what do I need to find next? Sorry. Starting point is what? How do you find your starting point? You're going to have the junk inside the parentheses, set that equal to 0. And where's your ending point? You're going to have the junk inside the parentheses and set that equal to 2 pi. How do I check that my period is correct after I find my starting and ending point? If I take the absolute value of my starting point minus my ending point, it better equal my period every time. Do we all understand that? Yes? Do we all remember this? Okay? Now, when I graph this, you're going to have an X, you're going to have a Y, you're going to have a pattern, and then you're going to have the secant graph. This is exactly how your test looks. Okay? You're going to have your starting point, and then your ending point is going to be down here. How do I go from one point to the next point to the next point to the next point? You have to add your interval, add your interval, add your interval, and then add your interval again to get to your endpoint. Yes? Now, whenever you're looking at this problem, you need to then make sure that you are examining your amplitude. Your amplitude is going to make you look at your pattern, correct? This is the cosine pattern. What does the cosine pattern look like? Handlebars. My amplitude is positive, so does it still handlebars? Is it reflected? It's still handlebars. So if it's still handlebars, the pattern is going to be max, level, min, level, max. Correct? Yes? And you would put those physical numbers here. And I believe my level, just for the sake of this, is just going to be -3. My max is going to be -1, and my min is going to be -5. Okay? In this problem. So I would physically put those in here. So I'm going to have -1, -3, -5, -3, -1. Yes? When you do your secant graph, what do your levels become? Asymptotes. They become asymptotes, and you simply drop these over. Do we understand that? Yes? And when you graph this, it's going to look like this. Yes? But you are going to have asymptotes at your levels, and you're going to reflect this. Do you remember that, yes or no? Yes? It's crucial that you remember that. Okay, the next one that we need to talk about in the 2 minutes remaining is cotangent. Okay? Cotangent, does it have a true amplitude? No, it does not have a true amplitude, but the amplitude is there to help you with your high and your middle and your low, right? This is an increasing or a decreasing function, right? If the amplitude is negative, what happens to the cotangent? What does cotangent typically look like? This is cotangent, right? It's decreasing. But because this is with a positive amplitude. With a negative amplitude, it looks like tangent, doesn't it? Right? So you need to be very careful of that. Okay? You have high, middle, low. Your period. What is the period of cotangent? It is pi divided by the absolute value b. Number one mistake right there. Number one mistake. Your interval is found by doing what? Still the same, your period divided by 4. Now, what about your starting point? It's the junk in the parentheses, which is going to be the 4x plus the pi, but this time it's set equal to 0. And my ending point is going to be the junk inside the parentheses, and it ends up pi. What if I do tangent? Negative pi over 2 is the starting point, and the ending point would be positive pi over 2. Do you all understand that? Right? Okay. Well, here is your part A test. I expect this back to me. The very first day we are back from our weekend. Yes? Have a great day. Great weekend. I'll see you for the next video. Thank you. I will stop it now and do that.